Welcome to this maths course. This course will cover 3 topics from the GCSE at grade E, which is the new level 3. The topics to be covered are boundaries, fractions and ratio, with each topic containing questions to try, as well as explanations how to complete the questions. I hope you enjoy the course. In this question we are told that the weight of the bag of potatoes is 15 kilograms exactly. We are therefore going to look at the first decimal place to find the smallest possible weight and also the largest possible weight. We're looking for the smallest number that can round up to 15 and also the highest number that can round down to 15. We need to remember here that 0.5 can round both up and down when we're talking about boundary questions. So now, to complete this question, we write down that the bag of potatoes weighs 15 kilograms. There are no decimal places in this question, and so we will look to the first decimal place in order to find the smallest amount and the highest amount. So now we need to find the lower boundary for 15 and the upper boundary for 15. So we're looking for the lowest number to one decimal place that will round up to 15, which is 14.5, and that's our lower boundary. And we're looking for the highest number that will round down to 15 for the upper boundary, and that's 15.5. Our two answers therefore are 14.5 for the smallest weight it could be, and 15.5 for the largest weight that it could be. Here we have another question. This time the length of the line is 81 centimeters, and we need to find the lower and the upper boundary for that. Again, there are 0 decimal places, so we will look to the first decimal place to find the lowest number that will round up to 81 and the highest number that will round down to 81. So again, we can now complete the question. We first write down the figure of 81, and we know that since there are 0 decimal places, we will be looking to the first decimal place in order to find the lower and the upper boundary. We now look for the lower and the upper boundary, and to do this we move to the first decimal place and look for the lowest number that can round up to 81, and we find that that is 80.5. For the upper boundary, we look for the highest number that can round down to 81, and that is 81.5. This gives us the two possible answers of the lowest possible length being 80.5 centimeters and the greatest possible length being 81.5 centimeters. Now a question for you to try. The answer is given 30 seconds in, so pause the video if you need more time. In this example, we now have a number y which is rounded to one decimal place, and we have to find the error interval. The question is still the same. We need to find the lower boundary and the upper boundary, but because this is to one decimal place, we will need to look at the second decimal place to find these two values. We can now complete the question. So we now write down the number 5.2, and we know it has one decimal place, so we will be looking to the second decimal place in order to find the lower and the upper boundary. For the lower, we're looking for the lowest number that will round up to 5.2, and for the upper boundary, we're looking for the highest number that will round down to 5.2. So for the lower boundary, that is 5.15, and for the upper boundary, that's 5.25. And this gives us our range of numbers. So y is greater than or equal to 5.15 and less than 5.25. Now a question for you to try. The answer is given 30 seconds in, so pause the video if you need more time. In this example, we now have a number with two decimal places, and so therefore it will be necessary to look to the third decimal place to find the upper and lower boundary. Again, we can now complete the question. We first of all write out the number, which is 1.51, and we note that that has two decimal places, and so we're going to be looking at the third decimal place to ascertain the lower boundary and the upper boundary. The lower boundary is the lowest number that will round up to 1.51, and the upper boundary is the highest number that will round down to 1.51. The lower boundary therefore is 1.505, and the upper boundary is 1.515. In our answer, y is greater than or equal to 1.505 and less than 1.515. Now a few more for you to try. Pause the video after each question so that you can have a go before the answer is shown. In this first question, we have 2/5 plus 1/7. When you add fractions, the denominator, the bottom numbers, must be the same, otherwise you can't add them. To do this, we therefore need to make the 5 and the 7 the same, and we therefore look for the lowest common multiplier, or the lowest number that appears in both the 5 and the 7 times tables. Knowing that, we can begin the question. In this case, the denominator, the bottom number, becomes 35. 35 is the lowest number that appears in the 5 and 7 times tables. From there, we look at how we get each denominator to 35. To get 5 to 35, we multiply by 7. To get 7 to 35, we multiply by 5. We then take the top number of each fraction and do the same. 2 multiplied by 7 is 14, 1 multiplied by 5 is 5. 14 plus 5 is 19, so the answer is 19 over 35. Now a question for you to try. The answer is given 30 seconds in, so pause the video if you need more time. Again, we begin by making sure that the denominators, the bottom numbers, are the same. We therefore have to look for the lowest number that appears in both the 3 and the 5 times tables, which we can do by writing out 3 and the 5 times tables if we're not sure, and looking for the lowest number that appears in both. That's 15. We then look to see how we get each denominator to 15. So to get from 3 to 15, we have to multiply by 5. And to get from 5 to 15, we have to multiply by 3. We then do the same to the top number. 2 times 5 is 10. 3 times 1 is 3. And then we add them together. So 10 plus 3 is 13 over 15. Note that the denominator doesn't change. Now a few more for you to try. Pause the video after each question so that you can have a go before the answer is shown. This is our first multiplication of fractions questions, and this requires a different technique than when adding or subtracting fractions. To multiply fractions, you simply multiply the top numbers and multiply the bottom numbers. However, sometimes there may be large numbers on the bottom or large numbers on the top, and so consequently you can cancel down prior to multiplication. To do that, you would look to see if any of the bottom numbers can be cancelled with any of the top numbers. In this particular instance, we can't do any cancelling down, so we can now proceed to answer the question. So to complete this question, we have 3/4 or 3/4 multiplied by 1/5 or 1/5. We know there's no cancelling down to do prior to the multiplication taking place. So if we rewrite it as 3 multiplied by 1/4 multiplied by 5, and that gives us 3/20, which is our final answer. Now a question for you to try. Pause the video whilst you have a go at it. This is another multiply question. However, in this question it is possible to cancel down before we multiply. So we can see that we have 2/3 or 2/3 multiplied by 3/4 or 3/4. When we cancel, we're looking to cancel any bottom number with any top number. So 3 divided by 3 is 1, and 3 divided by 3 is 1 on the top, and then 2 divided by 2 is 1, and 4 divided by 2 is 2. So we end up with 1/1 multiplied by 1/2, which gives us a half. If we complete the question without cancelling, the question becomes 2/3 multiplied by 3/4. 2 times 3 is 6, and 3 times 4 is 12, so the answer is 6/12. 6 goes into 6 once, and 6 goes into 12 twice, with the final answer therefore being a half either way. In this next question, it's another multiply, but this time we have a whole number multiplied by a fraction. To convert a whole number to a fraction, you simply have to put it over 1. So 60 can also be written as 60/1. Knowing this, please have a go at the question and pause the video if you need to. So in this question we have 60 multiplied by 2/3 or 2/3. To begin, we first need to rewrite 60 as 60/1 multiplied by 2/3, and now we can look to cancel down. 3 goes into 3 once, and 3 goes into 60 20 times. We can only cancel top with bottoms, so there is no more cancelling, so 20 multiplied by 2 and 1 multiplied by 1, which gives us 40/1. And 40/1 can be written as 40. In this question there is a combination of adding fractions and then subtraction. We initially have to add the fractions in brackets and then take that result away from 1. You will need to use the skills that you've learnt in the previous lectures to complete this question. Have a go and then we will work through the answer. This question needs to be answered in 2 parts. The first part is to complete the addition of the fraction a half plus a sixth. As we have seen, the denominators are different and therefore we need to make the denominator the same. To do this, we work out the lowest number that appears in the 2 and the 6 times table, which is 6. To get from 2 to 6, we will need to multiply by 3, and to get from 6 to 6, we will need to multiply by 1. 1 times 3 is 3, and 1 times 1 is 1. So 3 plus 1 gives us 4/6. We can cancel this down to 2/3 by dividing top and bottom by 2. We now need to do 1 take away 2/3. To do this, we need to make the 1 a fraction by putting it over 1 and take away 2/3. So 1/1 take away 2/3. Again, we work out the denominator by looking for the lowest number that appears in the 1 and the 3 times table, which is 3. To get from 1 to 3 we multiply by 3, and to get from 3 to 3 we multiply by 1. 1 times 3 is 3, and 2 times 1 is 2. So we have 3 take away 2 over 3, which is 1 over 3. In this question we have a division to complete. To complete a division with fractions, we turn it into a multiplication by switching the second fraction round, so the bottom number becomes the top and the top number becomes the bottom. We first of all, however, need to change the 12.5 into a fraction. To do this we talk about complete sets. So we say that we've got 12 complete sets of 2 and 1 extra one. So 12 complete sets of 2 is 24, plus the 1 extra one gives us 25. So 12.5 is the same as 25 over 2. You will be able to see this when we work through the question. So we have the question 12.5 divided by 5 over 8. And to change the 12.5 to a fraction, we multiply the whole number by the denominator. So we do 12 times 2, and then we add on the numerator, the top number, which gives us 25 over 2. And this is how you can convert any mixed fraction into a fraction. So we now have 25 over 2 divided by 5 over 8. We now need to change this to a multiplication by switching the second fraction, and this becomes 25 over 2 multiplied by 8 over 5. We then cancel down. 5 goes into 5 once and into 25 5 times. 2 goes into 2 once and into 8 4 times. We therefore end up with 5 over 1 multiplied by 4 over 1. 5 times 4 is 20, 1 times 1 is 1, and 20 over 1 equals 20. Now a question for you to try. Pause the video whilst you have a go at it. In this question we have 2 1/4 divided by 3/5. Again we are going to need to change the mixed fraction into a fraction, so that's 2 multiplied by 4 plus 1, which gives us 9 over 4 divided by 3/5. We then need to change this to a multiplication question, so we switch the second fraction, so 9 over 4 multiplied by 5 over 3. To cancel down, 3 goes into 3 once and 3 goes into 9 3 times. That leaves us with 3 over 4 multiplied by 5 over 1, which gives us 15 over 4. And if we change that into a mixed fraction, we can get 3 complete sets of 4 out of 15, with 3 left over. So that's 3 3/4. In ratio questions, we are looking to see how a quantity may be divided up into different parts. There are a couple of different types of ratio questions, but in the initial question that we're going to be looking at, we need to look at how many parts there are in total. We get this by adding together the ratios and then dividing the amount by the total number of parts. We will see this as we proceed through the question. So here we have a quantity, an amount of 45 centimeters, and we need to split this into the ratio of 7 to 2. So to begin with, we need to work out the total number of parts, which we do by adding together the ratios. 7 plus 2 equals 9. We then need to work out what each part is worth, so we take the amount, the 45, and divide it by 9, which gives 5. And then we can work out this according to each ratio. So one ratio is 7, so 7 lots of 5 is 35 centimeters, and the other is 2, so 2 lots of 5 is 10 centimeters. When we add them together, we should get back to the total amount that we started with. Now a question for you to try. Pause the video whilst you have a go at it. In this next question, it is a ratio question combined with a fraction question, and so we need to work out the ratio first and then work out the fractional part of it. We can see this as we go through the question. So in this question we have Melissa, who is 13 years old, Becky, who is 12 years old, and Daniel, who is 10 years old. And these are going to form our ratios, so we need to add them up first of all. So 13 plus 12 plus 10 gives us 35 different groups by which we must share out the £28. So we now need to do 28 divided by 35. And this may seem difficult at first, but actually if we cancel down the fraction and we say that 7 goes into 28 4 times, and 7 goes into 35 5 times, we're left with 4/5. And 4/5 is 0.8 as a decimal, so 80 pence. We now need to work out how much Becky's going to get, so we're going to do 12 times 80 pence. And this is 10 times 80, which is £8, and 2 times 80 pence, which is £1.60, so £9.60 in total. Becky now gives a third of her share to her mother. Now because she's giving a third away, we can say that she's got 2/3 left, so we now need to work out 2/3 of £9.60, and that gives us £6.40. So this might seem quite tricky to do at first, but we can say that 3 goes into 3 once, 3 goes into 9 3 times, and into 6 twice. So 1/3 is £3.20, and if we multiply that by 2 to get 2/3, we end up with £6.40, which is our final answer. This is another question with two parts to it. We first of all need to work out how much Anne and Bob get from the £240, and then how much they each give to Colin. Have a go at it and then we'll work through it together. So to work out the amount that Anne and Bob get, we have a ratio of 3 to 5, and so when we add those together, 3 plus 5 gives us 8. The amount is 240, so we do 240 divided by 8, which gives us 30. And now we multiply by each of the ratios. So Anne gets 3 lots of 30, or 3 times 30, which is 90. And Bob gets 5 lots of 30, which is 150. Anne now gives away half to Colin. So to work out that, we do 90 divided by 2, which gives us 45. And Bob gives away a tenth to Colin, and to calculate that we do 150 divided by 10, which gives us 15. So Colin gets 45 plus 15, which is 60. So to work out the fraction that Colin gets, we do 60 over the total amount, which is 240, so 60 over 240, which we divide through by 10, and that allows us to take off the zeros. That gives us 6 over 24, and then 6 goes into 6 once, and 6 goes into 24 4 times. And that gives us a final result of 1/4. Another two-part question for you to try. Have a go and then we'll work through it. So in this question we need to work out what 4/5 of 75 is. And to do this, we divide 75 by 5, and we can do this. 5 goes into 5 once, and into 75 15 times, so 1/5 is 15. And then if we multiply that by 4, we get £60. This is then divided in the ratio of 2 to 3, so 2 plus 3 equals 5. 60 divided by 5 gives us 12, and then 2 times 12 equals 24, and 3 times 12 equals 36. In this question, you need to use the ratios in order to work out a total amount, and so there's a slightly different question that we will need to work through. In this question, we know that there is 5 schools, and we know that one school sent 16 boys, and we also know that the same school had a ratio of 1 to 2 to the number of boys to girls that it sent. So from this, we can work out how many girls they sent to the conference. And we do it by writing out the ratios of boys to girls. So boys had a ratio of 1 and girls had a ratio of 2. We also know that there were 16 boys sent to the conference, so we write this under the boys ratio. We now look to see how we got from the 1 to the 16, and we find that we had to multiply by 16. We now apply this to the girls ratio, so 2 times 16 is 32. So in total, this school sent 16 boys and 32 girls, which is 48 children in total. We know that there was 5 schools that attended the conference, and they all sent the same amount of children, so 48 times 5 gives us 240 children in total. Now a question for you to try. Pause the video whilst you have a go at it. In this question, we know that Kerry's take-home pay was £15,000, and we also know that she spent 40% of her take-home pay on rent. So we need to take the 40% off the 15,000. So to work out 40% of 15,000, we do 10%, and to get 10% of something, we divide by 10. So 15,000 divided by 10, £1,500. So 10% is 1,500, and therefore to get 40%, we need to multiply 1,500 by 4, and 1,500 multiplied by 4 gives us £6,000. We now need to take that away from the 15,000, so 15,000 take away 6,000 gives us £9,000 left. We now need to divide that into the ratio of 3 to 1 to 2, so 3 plus 1 plus 2 gives us 6, and we now need to do 9,000 divided by 6, and that gives us 1,500. To work out how much she spent on entertainment, we need to look for the correct ratio, which is the ratio of 2, so 1,500 multiplied by 2 equals 3,000 on entertainment. Now a question for you to try. Pause the video whilst you have a go at it. So in this question we know that there is going to be some concrete mix, and that he needs to mix the cement and gravel in the ratio of 1 to 3 to 5. So consequently we need to add those up, so 1 plus 3 plus 5 is 9, and 180 divided by 9 gives us 20 kilograms. So that means that each part has to be 20 kilograms. Now this is mixed in the ratio of 1 to 3 to 5. So for cement there's going to need to be 20 kilograms, so 1 times 20. For sand there's going to be 3 times 20, which is 60 kilograms of sand. And for gravel there's going to be 5 times 20, which is 100 kilograms of gravel. Talil has 15 kilograms of cement, and that isn't enough, so unfortunately he won't be able to make the concrete mix.